All right, let's review the flow of your topic so far. You press stat edit, you put data into the tables. You would have had like a little scatter plot like this. And then Lynn Reg drew a line of best fit through that. Last lesson, do you remember what those plots were called? They started with an R. The ones where we looked for a pattern, yep. Residual plots. And so then you learn how to draw a residual plot. And what we established is if your residual plot, the dots around the residual plot were randomly scattered, then linear is appropriate, right? Now, if we had a residual plot where the dots formed a distinct pattern, so if we did a residual plot and you saw this in your residual plot, we would say linear is not appropriate, okay? Now, if you're a method student last year, you'd be aware that there's very, very many different models, like sine waves, logarithmic, that sort of thing. We only try one in general maths. The only one we try is exponential, okay? So the exponential model that we try in general maths is in this form. Y is equal to a times by b to the power of x. Y is the dependent variable, x is the independent variable. What do you notice here? X is a power. You're not timesing by x, you're raising something to the power of x. What's useful about a? A is the y-intercept. In context, it's the starting value of the dependent variable, so it might be the starting number of wombats on Tasmania, and then it's going to grow exponentially. B is known as the multiplier. It is what y is multiplied by whenever x increases by 1. The tricky thing with B is that if you express it as a percentage, then you can interpret questions like this. So let's demonstrate that here. For example, I've got this model here, y is equal to 2 times by 1.23 to the power of x. I've told you that a is the y-intercept. It's the starting value. So in this model here, what would y start at? What number is a in that model? 2 or 2? So y starts at 2. That's how we interpret that. And then I told you here that if I do b take 1 and expresses it a percentage, we can work out what y increases or decreases by. So here you can see b is 1.23. 1.23 take 1, what's the answer to that going to be? 0.23. So how do we interpret that? Y will increase by 23% for every x. Every time x increases by 1, this model is telling me that y is going to increase by 23%. That's how you interpret that model, because you're going to need to put it into context later. It's going to be animals, it's going to be car accidents, I don't know. But as soon as you see that model, this tells me something, and this tells me something as well. Let's do the same thing for a b that's less than 1. What would the y start at for this model here? 3 times by 0.75 to the power of x. 3. Y will start at 3. But now b is smaller than 1. So what's 0.75 take 1 going to be? Is that going to be a positive number or a negative one? It's going to be negative 0.25. So y is going to increase this time or decrease? Good. It's going to decrease by 25% for every x. Can you please add those to that so that you have a little warm-up to interpreting this model? It's new. It's different to linear. Linear had a slope and a y-intercept. This has a multiplier and a y-intercept. Get that down. I'll give you a minute or so. You'll need your calculator for the next page, so please get it out. All right, let's go. This is how you do an exponential regression. Have you seen how to do a linear regression so far? Number 4, lin reg. It's in the same place. So you put your data in, stat, calc. You scroll down to 0. See how the bottom one is 9? So that means 0 is below that. You need to scroll down all the way. Can you see exp reg? Yeah. So that's how you do it. What was the habit that I suggested that you form? You put your X data in list 1, Y data in list 2. Did you have a question or was that? And then you calculate it, okay? So that was what those steps were. We might as well just do an example for this. So we are going to run, we'll start answering this question. The mass of bacteria in a culture for our bio students is measured each day for 5 days. Draw a scatter plot of M against T. Can you please draw that scatter plot on your sheet? 1 is 3.6. 1 is going to be somewhere 3, like here. 2, 5.7. 5. 3, 9.1. 4, 14.6. 5, 23.3. Add those dots there. I'm not getting a micrometer out and measuring exactly where you put them. They just have to be in vaguely the right place, okay? The grids that you're going to have in your exam are tiny. So it just has to look like it's in the right place. How do I put data into the calculator? What do I press? I keep asking you because I want to hammer it into your head. Where do I put data in? Stat. Put that data in for me, please. 1, 2, 3, 4, 5 in X. Because does it make sense that the number of days determines how much bacteria has grown? Bacteria have no power over the passage of time, so it's not going to be the other way around. 3.6. 5.7. So I've put my data into the calculator and it's asking me, can you find the exponential model for the data in the form m is equal to a times by b to the power of t? Someone remind me, how do I find the exp reg? What do I press now? I've put the data in. Stat. Calc, scroll down to 0 and go exp reg. My X data is in list 1 because that's a habit I formed. Y data list 2. Go down to calculate. See how it's given me that model? So my model is the mass of bacteria, M, is equal to 2.25 times by B, which is 1.60 to the power of the number of days, and I rounded that to 2 decimal points. That's how you get the model. But it didn't ask me for it, so I'm not even answering that question. So that's a good question up here. She was asking, diagnostics weren't on. It didn't ask me for what RNR squared are. Interpret the values of A and B in context. Well, that's similar to what we just did before, adding to here. According to that model there, what was the starting mass of bacteria? Which of those two numbers, 2.25 or 1.6, tells me what it started at? Good. Yes, exactly. So the interpretation of this is that A tells us that the mass of bacteria started at 2.25 grams. And then how did we interpret B? You do B, take 1. So B take 1 is going to equal 0.6. What's 0.6 as a percentage? 60%. So what is that multiplier telling us about the amount of bacteria per day? It's going up by how many percent? 60%. That's how you interpret this. So suddenly there's context now. It's not just a number that's going up by 60%. It's amount of bacteria That's how you interpret it. So therefore, B tells us that the mass increases 60% each day. Because what is the X variable? It's days. That's how you interpret that. Can you get that down, please? And then I just need to show you how to answer the 2 question types that SACE likes to throw at us for these kind of questions. So here. You boys look tired. You're a bit young to be tired. Turning 39 in a couple of weeks. Not tired?
Oh, you're 38?
Yeah. 1986.
Really?
Sorry.
You're looking quite well for someone who's 38. We were young.
You only feel how you act. It's the blood.
I thought you were
It's genetic. Huh?
Oh, wait, no, you say you've been here for how many years was it again? 15 years?
I've been teaching for 15,
Yeah.
And it's all been here.
And you still haven't figured out where that cinder block came from? Or...
No, I didn't, until this year, I didn't know what Siberia was. I'd never taught up there. I'd never even had a relief up there.
Oh, lucky you.
Lucky me. Now my care group's there. I have to walk back and forth. Gets the steps in. All right, there are only 2 question types that you need to deal with once you've done this. So that's the flow of a question in SACE. A, draw the scatter plot. B, find the model. C, interpret what those numbers mean. And then they ask more technical ones that ask you to find either what Y is, or it asks you to find what X is. You'd want to hope that it's the Y one, because it's very easy. You just substitute and solve for Y. But solving for X, unless you've done methods, in methods, you guys that did methods, did you remember natural logs at all? ln? The way that you solve that, the way that you guys would solve for that, you would use natural logs. I made the mistake once that I taught how to do natural logs because I think it was a shortcut. And then the SACE exam asked a question where you couldn't actually solve it with natural logs. So I'm not going to do that again. I'm just going to show you, no shortcuts, how to do it with a calculator. That's what this is about, okay? So what we do in general maths is we graph both sides of the equation, right? So we graph both sides of the equation and see where the lines cross. We get the calculator to do the hard work. Okay, so I'm going to demonstrate how to answer these 2 question types. You've got these instructions next to you. So we're continuing that previous example. I need to rewrite the model here. So the model was this. 2 point, copy, I'm going to paste it here so I don't need to scroll back. That was my model. Predict the mass of bacteria in the culture after 7 days. So what is that question asking me for? Is it asking me for M, the mass, or is it asking me for T, the number of days?
M.
It's asking for M. That's the easy version of this because it's telling me what T should be. So all I need to do is in the model, M is equal to 2.25 times by 1.60 and raise it to the power of 7. Because T stands for the number of days. So that's not what that giant mass of instructions was for. 2.25 times by 1.6 to the power of, that little hat symbol above the divide sign is the power of this one here. The one that's highlighted in red. That's how we raise something to the power of in this calculator. To the power of 7. So that's telling me that the mass of bacteria is going to be 60.40 grams after 7 days. So hopefully that shows you why the instructions for that version of the question were not so long. Just replace the power with the number. E is the one that takes a lot of instruction, okay? So in your instructions, it should say something about, you need to write the equation down. So it's saying 100 grams. So M we know is 100 equals 2.25 times by 1.60 to the power of T. This is asking you how long is it going to take to reach this mass of 100. We don't do powerful enough maths in general maths to do the algebra to find T as a power. So what do we do instead? You grab the calculator, okay? In the calculator, you press the Y equals button. It's in the top left. It's just above second. And so what we do in Y1, put the left-hand side of the equation in. So what's the left-hand side of my equation? 100. In Y2, you put the right-hand side of the equation. So what's the right-hand side of my equation say? 2.25 times 10 to the power of 1.6. Sorry, 1.6 to the power of. Now, to get x on the calculator, can you see this button here that has x, t, theta, and n? That's how you get the x variable. Question? You press the y equals button in the top left. So y1, I've made 100. y2, let me demonstrate. 2.25 times by 1.6 to the power of the little hat symbol. And then to get x, I press this button here. That's like the variables button. To the power of x, okay? I want you to reflect right now. What are we asking the calculator to do? It is drawing a graph where y equals 100. So that's a straight line. At y is equal to 100. It's drawing that there. Can anyone tell me what an exponential graph look like? Is it a straight line? Does it curve up? Good. So that's what y2 is. y2 is drawing the exponential curve going up and up and up. If it's curving up, are they going to meet at some point?
Yes.
Yeah.
They're going to cross at some point, and that point there is the T that's the answer to the question. Okay? So how do we go through that process? You've asked the calculator to draw it now. When you press the graph button, we're not going to see a horizontal line. Why? Because that horizontal line is at 100. That graph only goes up to 10. So what you do, you press zoom, and you just zoom out until it crosses over definitely on the screen. So I went zoom out, and I'm going to press enter. Do I see a horizontal line on the screen yet? No, I just see the curve up. If I zoom out again, can I see a horizontal line on the screen now? So in blue, is the crossover definitely on the screen somewhere?
Yeah.
I don't need to see it clearly. I just need my calculator to see it. So after that, can you see there's a trace button above your arrows? What does the blue instruction above trace say? It says calc. So you need to press second trace. Which one of those options do you reckon would find the intersection? 5, intersect. So you go down to intersect. And this is going, what's the first curve? You just check in the top left. Is that Y1? Is that the Y1 that you entered? 100? Is that what we entered at the start? So you press enter. Is Y2, is that what I entered? Then you confirm that. You're just confirming things.
Yeah.
And then it goes guess. And it really irks me because it's like, I don't want you to guess the intersection. I want you to find it. I don't know why they said guess. But when it says guess, you press enter. And that tells you the intersection. On my calculator, it says the intersection is happening intersect at 8.07, 100. So that's the answer to the question. I can go through that after. Just wait. So therefore, how do I interpret that? It would reach 100 grams at 8.07 days to 2 dp. So I apologize that you have to do hell calculator work to solve this. If anyone has different on their calculator, I'll go through one by one and sort them out now. Okay, I'll start from here. So I'll pause the video there.